Hello, welcome. In this short video, let us look at the Kramer-Rao bound in the case of n observations with Gaussian distribution. That is, given the model x of n is equal to a plus w of n, where n is equal to 0 to n minus 1. That is, we have a sample of n observations with w of n having a normal distribution with mean equal to 0 and variance sigma square, which implies that x of n has a normal distribution with mean equal to a and variance equal to sigma square. Now our goal is to derive the CRB, that is Kramer-Rao bound, for the estimator a hat, where expectation of a hat is equal to a, that is a hat is an unbiased estimator. Now we want to derive the Kramer-Rao bound on the variance of this estimator a hat. So we start with the likelihood function of the parameter. It is defined as probability of x with the parameter a, where x is the set of observations xn, or the sample of observations xn, where n is equal to 0 to n minus 1. So the likelihood function is defined as the product n equal to 0 to n minus 1 probability of x of n with the parameter a. That is, this is the likelihood function for the nth observation, and the total likelihood function is equal to the product of individual likelihood functions, or the individual probabilities of x of n given a. Of course, here it is assumed that the random variables x of n are independent of each other. That is, x of n is independent of x of m, where m is not equal to n, is independent of x of m, where m is not equal to n. So in that case, the likelihood function is the product of individual probabilities, and this is equal to the product n equal to 0 to n minus 1. The probability of x of n given a is given by the normal distribution, that is the Gaussian density function, which is equal to 1 by square root of 2 pi sigma square exponential of minus x of n minus a whole square divided by 2 sigma square. Now the log likelihood function is defined as logarithm of the likelihood function, which is equal to logarithm of the product n equal to 0 to n minus 1 by square root of 2 pi sigma square exponential of minus x of n minus a whole square divided by 2 sigma square. So this is the log likelihood function. Now by using the formula that logarithm of the product is equal to sum of the logarithms, we have summation n equal to 0 and to n minus 1 logarithm of 1 by square root of 2 pi sigma square multiplied by exponential of minus x of n minus a whole square divided by 2 sigma square. So this can be simplified as n times logarithm of 2 pi sigma square power minus 1 by 2, so it becomes minus n by 2 times logarithm of 2 pi sigma square minus summation n equal to 0 to n minus 1 by 2 sigma square into x of n minus a whole square. The CRB for the estimator a hat is given by minus 1 by expectation of the second derivative with respect to a of the log likelihood function. So expectation of the second derivative. So the derivative of the log likelihood function is given by derivative of the this sum, which is minus n by 2 logarithm of 2 pi sigma square minus summation n equal to 0 to n minus 1 by 2 sigma square into x of n minus a whole square. And this is equal to, since the first term is independent of a, the derivative is 0, and the second term, the derivative of the second term is minus 1 by 2 sigma square summation n equal to 0 to n minus 1 2 times x of n minus a into minus 1. That's the derivative with respect to a. It can be simplified as 1 by sigma square summation n equal to 0 to n minus 1 x of n minus a. Now taking another derivative with respect to a, that is, we have the second derivative of the log likelihood function is equal to, the first term is independent of a, so its derivative is 0, and the second term is minus n minus a, the summation n equal to 0 to n minus 1 of a, so which is n times a. So this is derivative with respect to a of 1 by sigma square into n times a. Of course, there is a minus. So this is equal to minus n by sigma square. Therefore, the expectation of the second derivative of the log likelihood function is equal to minus n by sigma square. Therefore, the CRB of the estimator a hat is equal to minus 1 by minus n by sigma square, which is equal to sigma square divided by n. So this is the CRB on the estimator a hat. So thus, given n observations that are independent of each other and follow a normal distribution with mean equal to a and variance equal to sigma square, then the estimator of the mean a is bounded by, the variance of the estimator is bounded by sigma square by n. Thanks for watching.